right, so now we got to address this topic that we've sort of been dancing around up until now, and that is this idea of functional groups. Okay, so these are essentially collections of atoms that are special, and we group them together. Most sort of common, or I don't know if that's the right way to put it, but maybe the one that you're most familiar with would be the alcohol group. This is a functional group. We know that when we draw our bond line structures, we have to specifically identify these functional groups. They almost always consist of heteroatoms. Why do we call them functional groups? Well, I mean, that word functional is key there. Basically, by grouping things by their functional group, we can understand the types of reactions that these molecules like to undergo. Turns out that the back half of this molecule here isn't really going to be the key part of its reactivity. Those carbons and hydrogens are quite happy in their bonds with one another. Carbon and carbon in their bond with one another. And so it turns out that that polar hydroxide functional group or alcohol functional group is going to be the key driver of reactions of this molecule, right? So we're going to not only talk about the different functional groups, but eventually down the line, what we're going to do is group functional groups together and talk about the type of reactions that they undergo. We've got some groundwork to do, right? I mean, we had to first learn how to draw structures. Now we got to know what the different functional groups are. So there's some groundwork that we're laying in order to get to the point where we can actually sort of talk about chemical reactions. But again, so functional groups, we're going to introduce a few here. I apologize because this is going to be some memorization. I hate memorization, find it very difficult, but there's kind of no way around it. These are just things that you have to know because we're going to start talking about them and using them in discussion. And if you don't know what they are, then you're going to be lost. So let's start with the simplest ones, which are the hydrocarbons. So what we've been sort of building a lot of lately have been these hydrocarbons, and specifically ones that only contain only contain single bonds. Those are what are called alkanes. Okay, and this ane ending is going to be really important here. But an alkane is a hydrocarbon that consists only of single bonds. So then what if we introduce a double bond? This is what we call an alkene. So now my ending has changed from ane to ene. So these are alkenes. Alkenes are hydrocarbons. They can consist of single bonds, but they have to consist of at least one double bond. Then the next natural sort of next step would be, well, what about if there's a triple bond in there? And those are alkynes. Alkynes, again, they can have single bonds, but they must have at least one triple bond. So these are all hydrocarbons. They only contain carbon and hydrogen. But then single bonds are alkanes, double bonds are alkenes, triple bonds are alkynes, a Y-N-E ending. All right, so now let's get on to these special heteroatom functional groups. Like we said, alcohol is the OH group, okay? This is actually also called a, hydroxide group. Although usually, so it would be a hydroxide group. Hydroxide, remember, is OH minus. Okay, so that would be, that's a hydroxide ion. So a hydroxide group would be that OH or an alcohol group. Has to be an OH though. If there's a carbon bound to the other side of that oxygen, so for example, something like this is an oxygen that's been inserted between two carbons. This is what we call an ether. Also, just want to sort of note something here. You'll see these abbreviations a lot, where the interesting part of the functional group is explicitly written, for example, OH, or here this oxygen in the middle. And the other stuff is represented by an R. That's whatever else the molecule is. It's sort of focusing in on one component here. So when you think R, you want to think like an alkyl group or something like that. Okay, and then the last sort of similarly related to an alcohol would be an SH group, right? So oxygen and sulfur are in the same column on the periodic table. So these guys behave fairly similarly. And this is what we would call a thiol. Okay, so moving on here, the next compound that we have, the next group that we have, is going to be the amines. Okay, so amines are nitrogen-containing organic molecules. A primary amine is when there's one carbon-nitrogen bond. Then you have what's called a secondary amine. That means that you have two carbon-nitrogen bonds, or a nitrogen that's bound to two different carbons. And then you guessed it, a tertiary amine, and that would be a nitrogen that's bound to three different carbons. Okay, all of those are amines. An amine is just the general word for a nitrogen-containing compound. And then you have primary, secondary, and tertiary, right? So we don't know much about these compounds yet, but we should know for these four presented about like something like relative boiling point, right? So we're sort of building a little bit of our knowledge here. The last class is the alkyl halide. So alkyl is a prefix meaning that it just contains an alkane, right? So just a hydrocarbon on the other end without any double bonds or anything special right there. An alkyl halide means that that alkyl group is bound to a halogen, okay? So we can have every different type. An alkyl fluoride just means that there's again, this would be the alkyl portion, and then bound to a fluorine. Alkyl chloride, alkyl bromide, and lastly, an alkyl iodide. I'll just tell you, these two right here are the most important that we're going to see sort of over and over again. They're the most common. Yeah, so we're just going to see a lot of that. So they may be referred to either as an alkyl halide or more specifically as an alkyl chloride or an alkyl bromide. Okay, so I've sort of broken the functional groups up into two different things. This next class all contains what is called a carbonyl group or a carbonyl bond. So this is very specifically the bond that I'm talking about when I say a carbonyl bond, a carbon double bonded to an oxygen. So this is the carbonyl bond. This we would call a carbonyl, carbonyl oxygen. And here would be a carbonyl carbon. Okay, so this is a very important functional group in organic chemistry. Carbonyl, I'm referring specifically to that bond, and then there are many different functional groups that contain carbonyls. The simplest one being an aldehyde, okay? And that is when you have a carbonyl group or carbonyl bond on a terminal carbon in your chain. So important feature of an aldehyde is that this carbonyl carbon is bound to a hydrogen on one side. And then you have your ketones, which is when there isn't a hydrogen there, but instead, in this case, for example, a CH3 or any sort of an alkyl group, right? So your carbonyl carbon is bound to two other carbons. That would be a ketone. So those are our simplest carbonyl compounds. The next four we're going to lump into this group called carboxylic acid derivatives. Called carboxylic acid derivatives. And we'll see that's because they're sort of easy to interconvert into one another. Their reactivities are very similar, so we group them together. First, we'll start off with what a carboxylic acid is. So that contains this carbon that's bound to, double bonded to one oxygen and then bound to an OH. So it's almost like it has a carbonyl group and an alcohol group on the same carbon. We call that a different thing altogether. It's a carboxylic acid. And that means, of course, that this proton right here is acidic, okay? Everybody take a second and pause and see if you remember what I mean by is acidic, right? Something that we should have learned in general chemistry. Right, so remember, an acid is going to be a proton donor. So this compound readily donates that proton. And so we actually will talk a lot more about this in our next week, which is acids and bases. Okay, so then another carboxylic acid derivative, it's really easy to turn a carboxylic acid into what's called an ester. And an ester is very similar, except instead of having an OH, you see that you have actually an oxygen bound to a carbon on the other side. So in this case, it's a methyl group. It could be any sort of an alkyl group. But yeah, bottom line is it's not a hydrogen anymore. It's replaced by an alkyl group. We also have the acyl halide, not an alkyl halide, but now an acyl halide. And that is going to be that carbonyl group where the carbonyl carbon is bound to a halogen. So this more specifically would actually be an acyl chloride, but it could have been an acyl bromide, anything. So the broader class being acyl halide. That word acyl accounts for this portion of the molecule here. This is another way of saying that this, you could call this group an acyl group. Okay, so this is an acyl halide. Okay, and then the last group that we have here is an amide or an amide. I actually call it an amide, but I feel like most people call it an amide. I'll probably flip back and forth between the two, but anyways, yes. So an amide here, and that is now we have our carbonyl carbon bound to a nitrogen. This was a primary amide. You could also have a secondary or a tertiary amide as well, similar or analogous rather to what we saw with amines. Right, so unfortunately, organic chemists decide to name these two nitrogen-containing compounds pretty similarly. If it has a carbonyl group, it is an amide. If it does not, it's an amine. Okay? So again, these are just kind of memorization. You're going to have to practice these. The quizzes are going to be important. But next, once you finish all that, we'll start talking about formal charges.